Hello everyone, welcome back to Math with Allison. Today we're continuing our series on limits. Go ahead and make sure you check out some past videos here. Make sure to click that little link in the corner. Otherwise, today we're talking about limits, specifically horizontal asymptotes. So we're just going to go ahead and dive into it. Question of the day, what is a horizontal asymptote? I have some pictures for us here, and very similar to vertical asymptotes, it's a value that our function, we can see our function is here in blue, gets really close to, but never quite touches. Notice here that it does actually touch the horizontal asymptote right here, but I'm talking about when we go out to infinity and when we go out to negative infinity. It gets really, really close, we're coming in on top, but it never quite hits it. So we have another example here, this one's pretty similar. We have a horizontal asymptote at y equals -1. The reason it's y is because it stabs the y-axis at -1. And so again, our function does hit it, but as x goes out to infinity, our function is getting really close to it, but not touching it. Same thing on the other side, we get really, really close to it, but we never quite hit it. So let's go ahead and look at a formal definition of this. We have the limit as x approaches infinity of f of x is equal to some value L. In our above example, this number would be -1. That would be our L. Or the limit as x approaches negative infinity of f of x is also equal to L. In our case, it'd be -1 again. So a very common example we have is the limit as x approaches infinity of 1 over x. This one actually has a horizontal asymptote, and let's go ahead and look at our graph to see where. We can see horizontally, it gets really, really close to x equals 0. But it never quite touches it. And so I'm going to go ahead and fill this in. The limit as x approaches infinity of 1 over x is equal to 0. Same thing with negative infinity. It's equal to 0. It never hits the x-axis. So we would write this as the line of y equals 0. Because again, it stabs the y-axis at the value 0. So, question though, how do we find horizontal asymptotes when we're just given a function? So I have a function right here with the limit as x approaches infinity of x squared over x squared plus 4. What we want to do is evaluate the limit, because whatever the limit equals is going to be our horizontal asymptote. So let's go ahead and do that. I'm going to take the largest power of x that we have. In our case, our largest power is x squared. And I'm going to go ahead and divide every single term by x squared. If you want to figure out how I did that, go ahead and make sure you click on my previous video. I go over it in greater detail. So what I'm going to do now is simplify. And now I'm going to go ahead and look at my limit. My 1 right here and my 1 right here don't change because they don't involve any x's. But this term right here, as x goes to infinity, this is going to approach 0. So when I evaluate this, I get 1 over 1 plus 0, which is equal to 1. This tells me what my horizontal asymptote is. X squared over x squared plus 4 has a horizontal asymptote at y equals 1. That's how I would write it out all officially. But we do have a shortcut to this process. What I'm going to do now is we have the same function, but I'm just going to take the leading terms of the numerator and the denominator. So in this case, the leading term is the only term in the numerator, and my leading term down here is just whatever x has the highest power. So I'm going to rewrite this. And now I'm going to simplify, right? X squared divided by x squared is just 1. And when we have the limit of a constant is just a number, that's what it's equal to. It's just equal to 1. And so we get the exact same value, but with less work. It's a bit of a shortcut. The first part shows what's going on behind the scenes. The second part is just a little way to get you there. So let's go look at types of problems. In our previous example, we have problem number 1, where the degree in the numerator is equal to the degree in the denominator. So then the limit is equal to the quotient of the leading coefficients. So in our first example, the leading coefficient is a 1 and a 1. So I get 1 over 1, which is equal to 1. And that matches what we did earlier, right? I have a different example so we can see what this looks like. What I'm doing is I have powers that are even, right? X squared and x squared. Those are our leading terms. So now what I do is I take their coefficients and I get 2 over -3 or -2 thirds. And that is our horizontal asymptotes. Y equals -2/3. Another type of problem we can see is when the degree in the numerator is smaller than the degree in the denominator. So let's go ahead and work this out again. I'm going to take the largest power on both the top and the bottom. And now I'm going to go ahead and simplify that. Well, I know what this approaches. It approaches 0. So whenever the degree on top is smaller than the degree on the bottom, then the limit is equal to 0 and the horizontal asymptote is at y equals 0. We have one more and it's reversed of this one. So the degree in the numerator is larger than the degree in the denominator. Any guesses? Let's work it out. So let's take the limit as x approaches -infinity, and again, I'm just going to take the largest powers. Be careful because sometimes it's not written in order, so just make sure you grab the highest power. I'm going to keep their coefficients, that's what we're supposed to do, -x², and I'm going to go ahead and simplify that. Okay, so now when I evaluate my limit, I'm plugging in -infinity. Except that -infinity is being squared. Whenever you square a negative number, we get a positive number. So now we have -4 times a really big positive number. A negative times a positive is equal to a negative. So actually this approaches -infinity. So the limit in our case was -infinity, but it can also be positive infinity. So the limit is positive infinity or -infinity. And there are no horizontal asymptotes, or there is none. So when the degree in the numerator is larger, we have none. When the degree is smaller, we have a value of 0. And when they are equal, we take their leading coefficients. So that's all I had for us today on horizontal asymptotes. I hope you all enjoyed this video. If you did, please leave a thumbs up and comment other problems you'd like to see done or topics you'd like to see. Thanks for watching.